All right, so we are here today, yeah, all together to understand a little bit about DevOps, right? I see many participants are still joining. Yeah, so we are going to understand what is DevOps, right? So we have a brief introduction to DevOps. We are going to understand the DevOps lifecycle, right? Then we are going to understand two specific parts of lifecycle, which is CI and CD, right? And then we are going to understand pipelines, right? Basics of pipelines and how do we achieve it, right? And we will also try to differentiate between continuous delivery versus continuous deployment. So we are going to do that as well. And then finally, we'll take a look at Jenkins and we'll try to understand how we can use Jenkins to achieve our pipelines. All right. So they're going to be a little bit demo, a small demo for Jenkins, and rest of the things will be purely theoretical. Okay. One thing before we start is if you have a question for me, please do not ask questions in the chat because as you can see, there are so many messages on the chat. It's extremely difficult for me to keep up with all the messages, right? So if you are asking me any questions, please use the Q&A window. All right, so please ask me the questions on Q&A section. I will not be looking at the chats. All right. Okay, now I'll start with my introduction. My name is Amit. I have 17.5 years of experience in the industry, and around almost all of it has been on DevOps, so DevOps tools and technologies. So I have been there, done that with almost all the technologies. I have worked on cloud, version control systems, automation systems, CI/CD, Kubernetes, and everything related. Worked here as well. Yeah, we're going to talk about 1 hour. So I'm going to explain the topics for 45 minutes, right? And then for 15 minutes, we are going to take some questions. Okay. And because this is just a introductory webinar and we are so short on time, I won't be able to do any customizations here on the topics that we want to cover. All right. So let's talk about DevOps life cycles, right? So first, let's understand what is DevOps. Okay. Now I'm going to be very brief here. I can go into much detail, but I'm going to be very, very brief. DevOps is a combination of two words, right? It's dev and it is ops. But what does it try to achieve? What are we trying to achieve with these two, letter or two words and combining them together? What's the end goal? So let's understand what is dev and what is ops. Yeah. So dev is I would say a domain in software projects which involves with development of new products, right? So feature designing, feature implementation, bug fixes, right? Releases, coding. Whenever we talk about all this, testing, whenever we talk about all these things, we talk about actually software development, right? So software development is nothing but developing a product as per customer specification, testing it out for customers usability, and then delivering it to customer. Okay, so that's the dev activity in a software organization. Then there is ops. What is ops? Ops stands for operations. Once a software is developed, then taking care of the day-to-day, day-to-day sustenance of the software product is called operations, right? So once the software is developed, what happens? The software is deployed on an infrastructure, right? There is some sort of infrastructure. It could be virtual machines, it could be cloud or Kubernetes or whatever, and you deploy your application here. Yeah, mostly the web application. And then you have your end users who will access this application, right? Now, operations team's responsibility is to ensure that the application has the maximum uptime, right? Maximum performance, right? And minimum unavailability. Okay. So the development team develops the application, but the operations teams takes care of ensuring that the application is available for maximum amount of time to the end users with the maximum performance, so minimum latency, maximum throughput, and also minimum unavailability, right? So that means their work is revolves around taking care of the infrastructure, ensuring that the infrastructure has enough resources to run the application, ensuring that there are correct permissions defined, correct access available to the application, and also they also take care of deploying the updates, yeah, updates and upgrades to the application. Okay, because they have to ensure that there is maximum time and minimum unavailability. So they want to upgrade the application in such a way that it does not hamper the end user's productivity if they rely on the application, right? So the development teams have to deal with the application development. The operations have to mostly deal with the infrastructure and the operational activities of the application. Now, this setup actually poses certain challenges, right? First challenge is, and the major challenge is, if the development team is developing and releasing the product at a rapid speed, right? For example, they have releases every week. So week 1, they make a release of application. Week 2, another release. Week 3, another release. Every week, if they make a release, then the operations team has the responsibility to deploy every release in the infrastructure. That means upgrade the application as per the development team's releases, right? Now, delivering new release of an application every week is much easier when you compare it to upgrading the actual production application. Now, the operations team have to ensure that if the application is on week 1 release, and if they want to upgrade to week 2 release, then they have to ensure that there is no dependency on any other component which needs to be upgrades, and then the infrastructure supports the new application, right? And there is no performance degradation. So it's operations team's responsibility to perform all these checks before actually upgrading the application, because the operations team is answerable to the end users. If the end users face any issue with the application, they talk to operations team, not to the development team, right? Now, how do the operations team test all this? So when they receive a new release from the development team, they perform their own tests. And then based on the test results, they can accept or reject the release from the development team, right? One example would be, let's say the development team is they are developing a project, and in week 5 release, they say that, hey, our application is being developed on Java. So the previous releases were on Java 1.8. From week 5.11, our Java is upgraded to 1.11, right? So we are going to release it. The operations team should deploy it. Now, the operations team's infrastructure would be tested with Java 1.8. And let's say now they have tasked to upgrade to week 5. Then immediately they'll reject the release that, hey, we cannot release this because our infrastructure is running on Java 1.8. We cannot simply upgrade our infrastructure just because your application needs it. We have not tested the new version of Java. There are other applications on our infrastructure which need the older version of Java. So, hey, we cannot actually take care of your request. And that may result in rejection of the upgrade or the release. So what happens? The rejection goes to the development team, and development team says, hey, this is what it is. Either you upgrade the infrastructure or, take a call, answer your end users. In that case, the operations team may, take some necessary actions that are required. Maybe they upgrade, maybe they reject, whatever. But then that is a problem. There is a gap between the development team and the operations team, right? Development team wants to change the system. The operations team wants to ensure the system is as stable as possible. And the best way to ensure stability in any system is to not change anything. Yeah. Then how do we ensure this? How do we ensure that the development team is able to deploy everything and operations team does not have to worry about any changes impacting the larger infrastructure? So to achieve this, we make use of a concept called DevOps, right? So what we do is the dev team actually starts taking some responsibility from the ops team. Okay, this is called as shift left. So you shift some responsibilities to the left side of the life cycle. Yeah, the life cycle of the application, development, and then operations. You shift some responsibilities to the left side, right? So for example, the development team is responsible for the application development at the complete application development. Apart from that, they're also given responsibility to deploy and to operate and to upgrade and to observe the application. Now the operations team manages a huge infrastructure. So servers, network, things like that. What they can do is, and what they will do is to enable this shift left is they're going to give a little bit more flexibility to a subset of the infrastructure. Let's say there are 2 servers from the entire infrastructure that run this application. So the ops team is going to give the access for these 2 servers to the development team, right? Via some way. Maybe these are Kubernetes nodes, or maybe on Kubernetes, they give permissions to run some pods, whatever. They relieve some access for the development team. And then the development team, when they develop their product, the different releases of the product, week 1, week 5, week 10, when they develop all these products, the development team actually by themselves upgrades the product, right? So they manage the different versions of the applications, different versions of the products, and things like that. The operations team is responsible for the larger infrastructure, but just for the application and its related infrastructure, the responsibility is transferred to the development team. Now, end users, they still access the application, but the any problems faced by the end users is then taken directly by the development team. This is called DevOps. The development team also doing some ops work. And this is achieved using the shift left methodology, where you want to shift some responsibilities to the left side. Okay, hopefully it makes sense. So now let's talk about a little bit about the DevOps pipeline, right? When a development team has the complete control over their required infrastructure, how they can design their entire pipeline, how they can ensure that any new feature that they define is released to the production product. Yeah, so it can be done in this way. First of all, the development teams should store their code in a version control system. For example, Git. Git is a version control system, right? And all the code goes here. So the developers, this is the dev team, for example, the developers make code changes in the Git repository or version control systems. As soon as a change goes into the version control system, well, what you can do is, as a DevOps engineer, you can perform some tests on it, right? As soon as, if there is developer A, developer B, developer C, as soon as developer B or C or A submit their change to the code, it should be automatically tested, right? What tests can you do? First thing is basic compilation test. If your code needs to be compiled, well, does it compile actually after the change? That's the basic test. If it doesn't even compile, then there are bigger things to worry about. So you perform a compilation test. If compilation is done, then you can perform some unit test, right? You can also perform some system tests. Right? You can do some, maybe security checks. It depends on your use cases. You can do static code analysis or many other things. So you can perform some tests. Yeah, this is called and before I name the term. If compilation is okay, only then you perform unit test. If unit test and compilation both are okay, then you perform system test. If system test is also okay, then you perform security test. So these are all dependent tests that you perform. If any of the tests fails, you can immediately break the further checks and give the feedback to the developers. If it is not okay, so if you find some issues in unit test, you can immediately give feedback to the developers and say, hey, you need to fix your code. There seems to be some issue in the code. Either it's not compiling or it's not testing, unit test is failing or security checks are failing, whatever. So feedback is given back to the developers, and developers will get the feedback. They'll try to fix that and push again a new change to the code, which again submits it to these tests. Such kind of operation where you are continuously integrating the changes into your product is called continuous integration, also known as CI. Right? So continuously validating any code change being submitted into Git is called continuous integration. Now you can say, hey, Amit, if my code, any code that the developers are changing, If it is compiling, unit test is successful, system test is successful, everything is successful, then can I maybe automatically release it to the customer? Of course, if you think that these tests are enough and mature enough, and if they are able to perform all the checks that you want to for your product, then you can say, hey, any change that comes in, and if it goes through this entire test, and if it is successful, then you can, maybe I choose a different color, then it can be marked for delivery. What's delivery? Delivery means, hey, you can say, hey, my code is ready. Yeah. If my manager says release, I will release the latest code. So your code is always ready for deployment, right? So that means here somebody will manually approve, and then the result will be deployment. Right? So if all the tests are ready, you can say, if you are the team leader or the manager of the team, you can say, hey, my code is always ready to release, because any changes that are coming in are verified. So my change is ready to release. That means I can do continuous delivery. It is always ready with my boss. And when my boss says, hey, now deliver, then somebody delivers. It is immediate. Such a scenario is called as continuous delivery, right? So you can continuously deliver your product. Now you can say, hey, Amit, I understand this, but why do I need to do this manual approval? Why can't I say, hey, my tests are so mature that everything is being tested. So as and when a new code comes in and it is ready to release, I can actually deploy it to production. I can actually deploy to production. Right? So that means the end users will regularly, whenever a change comes and it passes all the tests, they will regularly see the latest changes in the production. Think of Amazon's website, right? They're always making changes to their website. You will always see some changes, like, they move some GUI elements here and there, they move some options here and there. All that is done continuously, regularly. Yeah, this is called continuous deployment. Continuous deployment. So you are deploying each change continuously, right? Now, this is the ideal situation to be in, that, hey, you have this setup, any developer making any change. So let me choose a different color here. So a developer, let's say developer B, makes a change to the system. The change is submitted to the Git repository, and it gets compiled, and then gets unit tested, and then gets system tested, and then gets security checked. If everything is okay, It goes and sits in production in real time. I made a change now. The steps take 15 minutes, and at the end, it goes to production. So my end users don't have to stay for a long time without the new features. They're always working on the latest features. Now it has its own pitfalls. Yeah, so you need to ensure that all your tests are so mature that you can 100% rely on them. You have to ensure that your documentation should accompany the code, and everything. You need to be just ensure that everything is as per end user needs when it goes to production, right? It's an ideal situation to have, but it's very difficult to achieve. So now I'm going to spend some time, maybe around 15 minutes, in setting up an a Jenkins machine to show you how it can work, right? So just give me a second. Let me fire up my AWS instance. In the meanwhile, you can ask me some questions if you have. Is it possible to cover Azure pipelines? Unfortunately, no. How to make sure that production deployment is always successful without impacting customers? There are many ways to do it. You can do blue-green deployment. You can do gradual rollout. Yeah. So rolling releases, or you can do I would say A and B, feature releases. So there are a lot of things that you can do. As dev are the testers, then what do you mean by feedback to dev team? Feedback about that particular test. Just give me a second. Yeah. Let me also share my browser. Okay, so I don't have any instances. Let me create an AWS instance. Implementing DevOps in AWS and Azure are the same, almost same, but there are different services. Azure has much better Azure DevOps pipelines and boards and things like that. AWS has AWS Dev Tools, so they have their own code repositories called code commit. Then they have code deploy and code pipelines. So there are all these things. It's not same, but it is very similar. More details about Git. Maybe in some other session, I can also talk about Git in detail. Where does sanity regression testing fits in the pipeline? All in the tests. So you can add, sanity tests, regression tests, smoke tests, user acceptance tests, whatever, in this yellow box. Can you please repeat the difference between continuous deployment and delivery? Continuous delivery means that you are ready for release. You're not releasing it, but you are publicizing or making it public information to your customers, to your management, that hey, you are ready to release, and that you do continuously. Deployment is actually releasing and deploying on the servers. Can we deploy in the runtime, as in when application is being used by end users? It depends on your deployment strategies, as I said. How can we avoid CI failures due to cache and unavailable containers? It looks like more of infrastructure and resources issues. So maybe look into that side. What is the process of getting users approval before deployment taken? It can be anything. You can set up your own automations. There is a provision in Jenkins where you can get manual approvals by your management. So yeah, when we skip the approval part, then only it's called the continuous deployment. Yeah, when you skip the approval part and then actually go ahead and deploy it in the runtime. Is it all part of application testing phase? No, actually, the application testing should happen before the code change gets into Git. Do we use Mac for CI/CD setup? You can use Mac, of course. How to choose CI/CD tools? Again, based on your requirements. Nowadays, the term DevOps called as DevSecOps. No, that is incorrect. DevOps is DevOps, but there is something called as DevSecOps as well, where there's a lot of emphasis on the security tests. So you want to ensure that your application is secure enough. Not just application, but the infrastructure on which it is being deployed is secure enough. So there are a lot of things there. If any users face any challenges, who will take care of DevOps team or Ops team? It depends. If it is related to the larger infrastructure, maybe the application servers have no network reachability, then it is operations. But the first point of contact will be the development team. Okay, there are a lot of questions. So let me get back to the demonstration. So this is my instance, and I'm going to connect to this instance via my local terminal. So this is a machine which I have just created. Yeah. And what I'm going to do is I'm going to install Jenkins on it just to show you how it can be done. So it's just these three commands first. So I'm not going to explain how am I doing things. I just want to show you a little bit of functionality on Jenkins. Okay, I know what is happening. Okay, what is it? Okay, so looks like Jenkins should be almost installed. Yeah, something is coming up. All right, Jenkins is up in the final stage of deployment. So yeah, this may take a few minutes to install all the required plugins. I'll continue to answer some questions. How to achieve master slave configuration on Jenkins? I can show this in some other session, definitely. How to integrate Jenkins in Azure DevOps? Maybe, yeah, that's a good topic for a next session. High priority issue needs to deploy within SLA. How can we bypass testing and deploy P1 issue? You can create a pipelines in a way that it bypasses the regular testing and deploys it in maybe urgent mode or something like that. Okay, I cannot answer your specific errors that you're facing in your setups because it may need more understanding of the infrastructure. Where TFS comes in CI/CD process. So TFS is a Team Foundation server, which is by Microsoft. You can say an on-premise version of Azure DevOps, but it's mostly a end-to-end DevOps system for everyone to use. Yeah, is developer can become DevOps engineer by learning tools. Of course, yes. How can we protect applications data using Shield? Maybe some other session. How can we okay, this is repeat. Um, what are the basic requirement to be DevOps engineer? So you should know many tools. So ideally you should know all the tools which allow you to set this up. Yeah. What is the purpose of Jenkins? So Jenkins is an automation framework which allows you to define pipelines and sequential dependent execution of tasks. That's it. Oh, you guys cannot see my terminal. Oh no. Okay. What I can do is maybe I can just say show my screen. All right. Okay, we are here. Let's see. Yeah. So this is Jenkins, and this is where I can set up a pipeline, right? For example, I have a code repository. Let's go to my github.com. And okay, just give me a second. Let's log in. Just 1 second. All right, so this is a repository. This is a Git repository which has Java-based source code. Okay, so if what I can do is in Jenkins, I can say, hey, let's create a task, right? And I'm going to create a pipeline for this. Now, again, it may be a lot of things that I'm showing you here. Some things you may understand, something you may know, you may don't. If you don't understand, it's fine. We may have subsequent sessions to talk about these, right? And then I can say that I want to run this pipeline with all the stages, right? So agents, any, and say stages. Maybe this one is a bit difficult to see. Let me see if I can zoom in a bit like this on this particular area. Yeah, stages and stage, yeah, and steps. I'm not going to go into much detail here. Let's say this stage is called clone the repo. Yeah, and the steps I'll say git clone the repo. And I define another stage like this. And I say stage is perform compile, right? And here is sh maven compile, something like this. I'll show you what it does. On the machine, I'm also going to say, hey, why did we disconnect? Yep. Yeah, Maven is required. So what I'm doing is I'm telling Jenkins that whenever there is a code change, yeah, for example, if I scroll up here, I can say poll SCM, and I can say every 1 minute do this, yeah, compile. Found colon. Something like this. Let's see if this works. Now let's say build now. Didn't work. Just give me a second. Okay, then in that case, Just give me a sec. Yeah. All right. So you can see here, there is already some code in this Jenkins repository, which actually will clone the repository. Don't worry about it. Clone the repository and then compile it and then test whatever tests are there, test it and create a package for deployment. Yeah. And you can see here, this entire test pipeline is running. So it clones the repository, it does the compilation, it is going to do the tests, it's going to run the packages. So now this pipeline, end-to-end pipeline is ready. And if I make any changes on this code repository, for example, if I make change in this file itself, let's edit it. And if I just enter a new line, for example, just a dummy change, then pretty soon Jenkins is going to identify this and start a new build. Yeah, see here, Jenkins identified that, hey, there was a code change made, so I'm going to run this pipeline, these tests on this code. So I'm going to clone the project. You can see here now, cloning the project, starting compilation again, and it'll do the tests and packages. So it's going to run all these stages for the code, and we can add more stages for delivery or deployments and things like that. So that's what I wanted to show you. You can use various tools. For example, Git I used Jenkins. I also used Maven for performing compilation and things like that. You can use Kubernetes and Docker to package your application and then deploy to production directly. So there are many things that can be done. Yeah, and this is essentially the DevOps philosophy. You do whatever is possible with as much um, um, automation as possible. Okay. Can chaos engineering be implemented in DevOps? Unfortunately, I'm not very familiar with chaos engineering, so please excuse me, I can't answer that question. CI/CD can be controlled with multiple environments. Yes, of course, you can. What are the criteria for continuous deployment? It's up to the team and organization, right? The basic criteria is your application should be tested well enough. So you should have the confidence on your application that's going to behave as per the expectation of the end users. Okay. Can you please highlight the tools that are required for developers to be DevOps? Maybe some other session I can talk about all the tools in detail. Yeah, but basically it should be some infrastructure as configuration management tool like Ansible or Terraform if you're working with cloud. Then you should know Git, of course. You should know either Jenkins or some other CI tool, maybe Azure DevOps or AWS DevOps tools. Containerization is gaining popularity, so Docker or Kubernetes, something like that. Yeah, Git and GitLab are the same. Uh, sorry, GitHub and GitLab, almost same. Yeah, but they are by different teams, by different organizations. They have a lot of different capabilities. So, yeah, but they solve kind of similar problems. I need Jenkins to run only change in master branch. Yep, you can do that. Any suggested courses for DevOps? There are a lot of courses by various training institutes and YouTube and many other training websites also. So yeah, make use of those. Can we do CD without implementing CI? Unfortunately not. CI is